Welcome to the Ethiopian Construction Channel. We are glad to have you here. Let us learn together. Today, we are going to learn about classification of structures based on structural system. This classification explains how a building carries loads and transfers them safely to the ground. Understanding structural systems is very important in civil engineering, architecture, and building design. There are four main types of structural systems we will discuss: rigid frame structures, truss structures, shell structures, and space frame structures. Let's go through each one step by step. First, let's talk about rigid frame structures. A rigid frame structure is a system in which beams and columns are connected rigidly. This means the beam-column joints are fixed and resist bending. In this type of structure, loads acting on the beam are transferred to the columns and then safely carried down to the foundation. Because the joints are rigid, both beams and columns work together to resist bending moments, shear forces, and axial loads. Rigid frame structures are very strong and stable, especially against horizontal forces like wind and earthquakes. That is why they are widely used in multi-story buildings, residential apartments, offices, and commercial buildings. Most reinforced cement concrete buildings, also called RCC buildings, use rigid frame structures. Steel frame buildings can also be designed as rigid frames. In short, rigid frame structures are strong, durable, and suitable for buildings with multiple floors. Now let's move on to truss structures. A truss structure is made up of straight members connected together to form triangular units. The triangle is the most stable shape in structural engineering. In truss structures, loads are carried mainly through tension and compression, not bending. This makes trusses very efficient and economical for long spans. Truss structures are commonly used where large open spaces are required without columns in between. That is why they are widely used in roof structures, bridges, railway platforms, factories, and industrial sheds. Steel is the most common material used for trusses, although timber trusses are also used in smaller buildings. Some common examples include roof trusses in auditoriums, truss bridges, and large hall roofs. So, truss structures are lightweight, strong, and ideal for long span constructions. Next, we have shell structures. Shell structures are thin, curved surfaces that carry loads mainly through their shape. Instead of relying on thickness or heavy materials, shell structures use curvature to distribute loads efficiently. Because of this, shell structures can cover large areas using very little material. This makes them both economical and visually attractive. Shell structures are commonly made from reinforced concrete and are used in domes, water tanks, auditoriums, exhibition halls, and stadium roofs. Examples include domes, cylindrical shells, folded plates, and hyperbolic paraboloid roofs. One of the biggest advantages of shell structures is their excellent load distribution. Loads are spread evenly across the surface and transferred smoothly to the supports. In summary, shell structures are thin, curved, efficient, and architecturally impressive. Finally, let's discuss space frame structures. A space frame structure is a three-dimensional truss system. Unlike ordinary trusses, which are usually two-dimensional, space frames extend in all directions. Space frame structures consist of interconnected struts arranged in a geometric pattern. This allows the structure to distribute loads in multiple directions, making it extremely strong and stable. These structures are ideal for covering very large column-free spaces. That is why space frames are commonly used in airports, stadiums, exhibition centers, shopping malls, and sports complexes. Space frame structures are usually made of steel or aluminum and are often prefabricated, which allows fast and accurate construction. To summarize, space frame structures are lightweight, strong, and perfect for wide-span modern buildings. So, to conclude, rigid frame structures resist bending through fixed beam column joints. Truss structures use triangular units for long spans. Shell structures rely on curved surfaces for efficient load distribution. And space frame structures are three-dimensional systems used for large open spaces. This classification helps engineers choose the right structural system based on safety, economy, and building requirements. Classification of buildings based on usage. We are going to learn about the classification of buildings based on usage. This classification explains why a building is constructed and how it is used by people. Buildings are designed differently depending on their purpose. For example, a house, a factory, and a hospital cannot have the same design. So, based on usage, buildings are mainly classified into 5 types: residential buildings, commercial buildings, industrial buildings, institutional buildings, and public buildings. Let us discuss each one in detail. First, let us talk about residential buildings. Residential buildings are buildings used for living purposes. These buildings provide shelter, comfort, and safety for people. They are designed to include spaces such as bedrooms, living rooms, kitchens, bathrooms, and balconies. Privacy, ventilation, lighting, and comfort are very important in residential buildings. Examples of residential buildings include individual houses, apartments, flats, bungalows, villas, hostels, and dormitories. Residential buildings can be single-story or multi-story, depending on land availability and population density. In cities, multi-story residential buildings are more common due to limited space. In simple words, residential buildings are places where people live. Next, let us discuss commercial buildings. Commercial buildings are buildings used for business and commercial activities. These buildings are designed to earn profit through trade, services, or professional work. Examples of commercial buildings include shops, shopping malls, offices, banks, hotels, restaurants, and cinemas. Commercial buildings require proper planning for customer movement, parking, fire safety, and accessibility. They usually have large open spaces, lifts, escalators, and good lighting. These buildings are generally located in busy areas such as city centers, markets, and business districts. So, commercial buildings are used for buying, selling, and business purposes. Now let's move on to industrial buildings. Industrial buildings are buildings used for manufacturing, production, processing, and storage of goods. These buildings are designed to house heavy machinery and industrial operations. Examples of industrial buildings include factories, workshops, power plants, refineries, warehouses, and assembly units. Industrial buildings require strong foundations, large spans, high ceilings, and good ventilation. Safety measures such as fire protection, emergency exits, and pollution control systems are very important. Most industrial buildings are located away from residential areas to reduce noise and pollution. In short, industrial buildings are used for production and industrial work. Next, we have institutional buildings. Institutional buildings are buildings used for education, healthcare, and social services. These buildings serve the public and focus on learning, treatment, and administration. Examples of institutional buildings include schools, colleges, universities, hospitals, clinics, libraries, and research centers. Institutional buildings are designed with special requirements such as classrooms, laboratories, wards, operation theaters, and offices. Safety, hygiene, accessibility, and comfort are very important in institutional buildings. These buildings must follow strict government rules and standards. So, institutional buildings are used for education, healthcare, and public services. Finally, let us discuss public buildings. Public buildings are buildings used by the general public for social, cultural, and recreational activities. These buildings are usually owned and maintained by the government or public authorities. Examples of public buildings include railway stations, bus terminals, airports, museums, auditoriums, libraries, community halls, and stadiums. Public buildings are designed to accommodate large numbers of people. They require wide entrances, emergency exits, clear circulation paths, and strong structural systems. Public safety, accessibility for disabled persons, and fire protection are very important in these buildings. In simple terms, public buildings are meant for public use and gatherings. To conclude, buildings can be classified based on usage into residential buildings for living, commercial buildings for business, industrial buildings for production, institutional buildings for education and healthcare, and public buildings for community and public activities. This classification helps engineers and architects design buildings according to their function and purpose. Classification of buildings based on height. We are going to learn about the classification of buildings based on height. This classification is used to understand how tall a building is and how its height affects design, safety, and construction methods. Based on height, buildings are generally classified into three main types: low-rise buildings, medium-rise buildings, and high-rise buildings. Let us look at each type in detail. First, let us discuss low-rise buildings. Low-rise buildings are buildings that have a small number of floors, usually 1 to 3 stories. These buildings have less height and simpler structural design. Examples of low-rise buildings include individual houses, small apartments, schools, small offices, and shops. Low-rise buildings are easy to construct and maintain. They usually do not require lifts and complex fire safety systems. These buildings are commonly found in rural areas, villages, and suburban locations. In simple words, low-rise buildings are short buildings with fewer floors. Next, let us talk about medium-rise buildings. Medium-rise buildings are buildings that have moderate height, usually between 4 and 10 stories. They are taller than low-rise buildings, but not extremely tall. Examples of medium-rise buildings include apartment buildings, office complexes, hospitals, and hotels. Medium-rise buildings require lifts, staircases, and proper fire safety systems. They are generally constructed using reinforced cement concrete or steel structures. These buildings are commonly found in urban and semi-urban areas where land availability is limited. So, medium-rise buildings are buildings with moderate height and multiple floors. Finally, let us discuss high-rise buildings. High-rise buildings are tall buildings with many floors, usually more than 10 stories. These buildings are designed to accommodate a large number of people in a limited area. Examples of high-rise buildings include high-rise apartments, corporate towers, hotels, and skyscrapers. High-rise buildings require advanced structural systems to resist wind and earthquake forces. They also need multiple lifts, emergency staircases, fire alarms, and safety systems. These buildings are mainly constructed in large cities where land is expensive and population density is high. In short, high-rise buildings are very tall buildings designed with special safety measures. To conclude, based on height, low-rise buildings have fewer floors. Medium-rise buildings have moderate height. And high-rise buildings are tall buildings with many stories. This classification helps engineers and architects choose the right design, materials, and safety systems for a building. Thank you for watching. We hope you found this video helpful and informative. If you enjoyed the content, like the video, share it with others. Subscribe to our channel for more professional construction content.